Now today is our first class, and today we are going to discuss about IPv4 addressing. Um, First of all, we will complete IPv4 addressing, then we will complete IPv6 addressing. So let's start it. So first of all, IPv4 address. What is IPv4 address? What is the structure of IPv4 address? First of all, an IPv4 address is made of 4 octet number. IPv4 address will be 4 octet number, and each octet in binary 8 bits. So total 8 into 4, total 32 bit in binary, and it is made with dotted decimal format. And decimal value will be 0 to 255. So total it will be 4 octet. Number one. Number two, each octet 8 bits, so 8 into total 32 bit in binary. And in decimal format, we have to retain with decimal format IP address. IP address we need to write it in decimal format. And decimal value will be 0 to 255. Say for example, 200.20.30.1. If we convert 200 into binary value, then it comes to 11001000. How can we convert it? By using this chart. This is very easiest chart. By using that, we can convert very easily to decimal value into binary value. That is 2 to the power 7 equal to 120, 2 to the power 6 equal to 64, 2 to the power 5 equal to 32, 2 to the power 4 equal to 16, 2 to the power 3 equal to 8, 2 to the power 2 equal to 2, 2 to the power 2 to the power 1 equal to 0, 2 to the power 0 equal to 1. So, if we need to take all those values by which if we add all those values, then it comes to 200. So first of all, we need to take 128 plus 64, it comes to 192. 192 plus 8, it comes to 200. So if we convert 200 into binary value, it comes to 1100100. Then we need to convert 20 into uh, 20 is the decimal value, 20 binary value. What will be the binary value of 20? We need to take the 16 bit on, and just 4 bit on. So 000101010 This is the actually binary value of 20. So 20 binary value is actually 0001010. Then 30 binary value. We need to take all these values, by which if we can add all these values, then it comes to 30. So it will be 16 plus 8. 16 plus 8, it will be 24. 24 plus 4, 28. 28 plus 2 equal to 30. So 0001110. That is the binary value of 30. Next one 1. 1 means only one you need to take. Then 70, then 1. So 200.20.30.1, this is actually your IP address, IPv4 address. If we convert it into binary, it comes to 81. It will be 81, then 81, then 81, then 81. So total 8 into 4, total 32 bit. It comes to total 32 bit. In the same way, we can convert also 190 to 160 100.10. This is an IP address. If we convert 192 in binary, it comes to 11, then 60. If we take 168, it comes to 10101100. It is 160 168. Then 100 we need to take 64 plus 32. 64 plus 32, that is 96. 96 plus 4, that is 100. So 011 00100 and 10, that is 00001010. So if we convert it into binary, it comes to this is 8 bit, this is 8 bit, this is 8 bit, this is 8 bit. Total, total, total is your 32 bit, right? Next one, that is we need to identify the class, your IP address classes. We know that IP address classes is basically five types of classes. Class A for 0 to 127, class B for 128 to 191, class C for 192 to 223, class D for 224 to 239, and class E for reserved, that is 240 to 255. So based on first octet, we can identify whatever the class it is. For A, class A 0 to 127 it is. So if your first octet in between 0 to 127, then you can identify that it is class A IP address. That means, say for example, 100.20.30.1. No matter rest of the octet, whatever the rest of the octet it is actually. So first of all, you need to identify your first octet. Your first octet is 100. So it is in between 0 to 127. 100 is in between 0 to 127. So it is class A actually. Next, class B. Class B in between 128 to 191. So 160, then 130, then 20.25. So 160 is in between 128 to 191. So it will be class B. It will be class B. Okay. Why it is class B? Because 160 is in between 128 to 191. Next, your class C. Class C basically is 192 to 223. This is the range, and based on that range, you can identify whatever the class it is actually. Okay. Now, class C is 192 to 223. This is an example of class C IP address 192.168.100.1. So it will be 192 to 223. And another one address is multicast address, that is 224.239. This is special type of address. OSPF use multicast address 224.005, 224.006. Deep version to use multicast address 224.00009. EIGRP use multicast address 224.00010. So in case of IPv4 address, there are three types of address actually. One is unicast address, another one is multicast address, another one is broadcast address. So we need to discuss later in next class, or next class we will discuss regarding all those things actually. Okay. So next point we need to discuss, that is, what is default subnet mask. What is default subnet mask actually? What is default subnet mask? In case of class A, by default 255.0.0.0, this is the default subnet mask of class A. And in that case, first octet is assigned for network, and rest of the three octet is assigned for the host. First octet is assigned for network, and rest of the three octet is assigned for host. Now, what do you mean by network and what do you mean by host? Network means, network is a logical domain actually. Within that domain, whatever the IP address within same network, they can communicate with each other without using any inter-networking devices. So it will be network. That means network dot host dot host dot host, and host means, by using host address, you can identify a specific device, a specific network device, specific network interface. Network interface means router interface, specific switch interface, or layer 3 switch interface, or firewall interface, or server NIC, whatever the IP devices it is, you can identify by using that specific host. So there is a network. First octet is assigned for network, and rest of the three octet is assigned for host. So in case of class A, you will get highest number of highest number of IP addresses per network. This is class A. And for class B, first two octet is assigned for network, and rest of the two octet is assigned for host. First two octet is assigned for network for class B. Just look at this. First two octet is assigned for network, and rest of the two octet is assigned for host in case of class B. So this is a example of IP address, class B IP address 150.160.100.1. This two IP address is assigned for network, and this one is IP address assigned for host. This one is IP address assigned for network, and this one is IP address assigned for host. So first two octet assigned for network, last two octet assigned for host. First two octet assigned for network, last two octet assigned for host. Okay. So first two octet is assigned for network, last two octet is assigned for host. Correct. In case of class C, if you have any problem, then please tell me if you have any problem. Okay.
Okay.
So in case of class C, first three octet is assigned for network, and last octet is assigned for host. So in case of class C, in a per network, you will get lowest number of IP addresses as compared with class A and class B. So in case of IP addresses example, that is 192.168.100.10, on another one is 100.20. So first three octet is assigned for network, and last octet is assigned for host. First three octet is assigned for network, and last octet is assigned for host. First three octet is assigned for network, and last octet is assigned for host. First three octet is assigned for network, and last octet is assigned for host. Okay. Next, class C. This is an example of class C, because it is and 254 host maximum will get 254 host. So first three octet is assigned for network, and last octet is assigned for host. First three octet is assigned for network, and last octet is assigned for host. First three octet is assigned for network, and last octet is assigned for host. And in case of class B, first two octet is assigned for network, last two octet is assigned for host. And in case of class A, first octet is assigned for network, and last three octet is assigned for host. Correct. Now come back to the last discussion we need to discuss about the subnet mask and the prefix length slash notation value, that is CIDR value, classless interdomain routing. So you can define also subnet mask, instead of writing subnet mask, you can define also slash notation value, that is prefix length value of each subnet mask. In case of subnet mask 255.0.0.0, then you can assign it /8. How can you assign it as /8? Let calculate the binary value of specific decimal value. Specific decimal value is 255, and if we convert it is in binary, then it comes to 81. So all those one bit means one, zero means off. So all those one bit it will be assigned as a slash value. So there are 8 bit on, there are 8 bit on. So slash 8 it will be your value slash 8, and rest of the values will be 0. So 255.0.0.0 it will be slash 8. Next slash 9, 255.128.0.0. 255 means all, all 8. 128 means 1 1 1, then 70, then 80, then 80. So it is slash 9. 255.128.0.0 it is slash 9. Then 255.192.0.0 it is slash 10. Why it is slash 10? In first octet there are 8 bit, and in last octet, in second octet, not last octet actually, in second octet, there are 2 bit. So 8 plus 2, it comes to 10. Within 32 bit, there are 10 bit each on. There are 10 bit each on. Okay. Now next point, next example, that is 225.224.0.0 to 255. 255. If we convert 255 into binary, it comes to the 8181. And if we convert into 224, it comes to people 1, then 50. So it comes to 8 plus 3, total 11. So it will become to 11 slash 11. So we need to define, and only on bit we need to define as a slash notation value. Correct. Next one, that is 255.240.0.0. 255 means 81, and if we convert it to 40, it comes to 1111. Why it is 1111? Because 128 plus 64 plus 32 plus 16. If we calculate all those values, if we add all those values past 4 bit, then it comes to 240. 128 plus 64 plus 32 plus 16. It comes to 240. Correct. So it is slash 12. Next, next one, just let's check it. That is 255.0.0. That is slash 16. First octet in binary, if we convert it, it comes to 81. Second octet it comes to 81, and rest of the 2 octet will be all zeros. So it will be slash 16. And the same way, if we convert TP 255.0, it comes to slash 24. 255 means 81. 255 means 81. 255 means 81. So it comes to slash 24. Slash 24. Correct. Next, just take it. Next,
Sir,
just
please
look at the
repeat
chart.
this one.
Yes.
Sir, please repeat this one.
This one, actually, this is the default subnet mask of class C, 255, 255, 255.0. If we convert this subnet mask into slash notation value, it
How
comes
we
to
get
slash.
24? I don't understand.
How we get 24? If we convert 255, first 255 8 bit, we will get 8 bit. Then second 255 we will get 8 bit, and in third 255 we will get 8 bit. So 8 into 3, it comes to 24. Correct. 8 into 3,
Yes,
it
sir.
comes to 24. Next, look at this. 255, 255, 255, but 255, it comes to slash 32. It comes to slash 32. Why it is slash 32? Because first 255 means 8 bit. Second 255 means 8 bit. 8 plus 8, 16. 16 plus 255 means 8 bit. Then 24. 24 plus 8, it will becomes to 32. It is slash 32. Class A 10.0.0.0 থেকে 10.255 255.255 class A, class B 172.16.0.0 থেকে 172.31.255.255, class C 190.160.0.0 থেকে 190.160.255.255। তাহলে ক্লাস এ হচ্ছে 10.0.0.0 থেকে 10.255 255.255 ক্লাস এ। ক্লাস বি হচ্ছে 172.16.0.0 থেকে 172.31.255.255 ক্লাস বি। ক্লাস সি তে হচ্ছে 192.160.0.0 থেকে 192.160.255.255। এটা হচ্ছে ক্লাস সি। ওকে, this is the private IP address range, and this private IP address range is not globally routed. So if you routing in your private network to internet, into the global, then you need to configure NAT. Then router will perform NAT. Router or firewall will perform NAT. Correct.